So hello, I'm back again, I guess, for part five. Before we go any further with the slides, I want to show you something with regards to covariance and Excel. So I'll bring up Excel, and I clicked on the f of x function item here, and I did a search for I just typed covar, and sure enough, there's a bunch of built-in functions here to get the covariance. Okay, this is P stands for the population, and I believe we would use the sample one, right? A sample one. So here's the sample one, and if I click on that, it says return sample covariance because that gives you the n-1 weighting. All right. So in any case, it's just something good to know about. Now, I don't know if this is population or covariance. I don't know which one this is here, but I think I would stick with these two. Okay, if you want one for the population and one for the sample. All right, so it's just good to fool around with this way. You get to the hang of it and get to use the data. All right, so here's a larger portfolio now. We go past two stocks, right? And it comes down to the variance of a portfolio is equal to the weighted average covariance of each stock within the portfolio. And I think, for my eyes don't deceive me, I think there's a mistake here. I believe that one of these maybe should be an RI, all right? Because if you look here, it's the sum of XI, RI, RP, okay? And again, there's an I there. So I don't have the book in front of me. I'll check that. And this reduces to this relationship here. And I know you're all going crazy at this point, but and that's equal to the sum of xi covariance ri sum xj and that comes out to the sum of the sum. It's a double sum here of xi xj covariance ri rj. I think people actually do this for a living, so I know this all looks crazy to you. So as I mentioned previously, this is the volatility of a large portfolio, and this is correct as shown. I didn't realize this was variance. So okay, so it all comes down to this equation again, which is a mathematician's delight. So over here we have equally weighted portfolios, and this will give you the variance of an equally weighted portfolio. You have this component, and you add this component. So I'm just going through this rather quickly because I really don't think you're going to be tested on this math, okay? And I doubt it. All right, so anyway, I just want to show you this graph is somewhat important, and it's just very intuitive. The greater the number of stocks I buy, okay, I eliminate diversifiable risk, okay? I eliminate diversifiable risk, and the only risk that remains is this portion right here, which is the market risk you can't get rid of, such as the risk we were living with now during this whole coronavirus thing, right? So we get rid of the diversifiable risk the more and more stocks I buy, except, of course, for this portion here. And this is the portfolio volatility, which you saw that I have to live with, okay? So it should be an obvious thing, though, that graph. All right, so there's an example here about portfolio diversification using different types of stocks. Okay, so some of them have a volatility of 40% and a correlation of 60%. And then there's international stocks here. Okay. So I guess you got domestic and international stocks here. So you can go over this example. Just breeze over it. It's not that important. So here is the solution. So here's the average covariance. Here's how you get the average covariance. And this, again, this is equation 11.12, right? And so the volatility is the average covariance. And here it is here, right? So you look at equation 11.12. And this volatility is again higher than when using stocks from different industries. And here's how you get superior diversification using international stocks. Some of my retirement is in international, but once again, diversification helps unless you're in a situation where you have systemic risk. Whoops, sorry about that. Alrighty. All right, so what's the volatility of an equally weighted average of an independent stocks? And here's the solution to that, all right? Here's the solution to that. It's very touchy, this thing. All right, so here's a portfolio with arbitrary weights. The standard deviation is calculated as follows. Now, I don't know if this is in Excel when it comes to all these weights and everything. You may be able to buy a financial insert for Excel if you wanted a lot of this stuff. You'd have to do this all probably by hand in Excel. All right, so I will pick up the rest of this in a bit.